A permutation is an arrangement of a set of integers 1, 2, 3 all the way to n in some order without omissions or repetitions. In the set 1, 2, 3, a permutation is going to be this set of numbers rearranged in some other order as long as none of the numbers are repeated. So 1 is not repeated, 2 is not repeated, 3 is not repeated, and none of these are omitted. 1, 2, 3, a permutation can be 2, 1, 3, 3, 1, 2, 1, 3, 2, 2, 3, 1, 3, 2, 1. These are all the exact same numbers, just rearranged. None of them are omitted and none of them are repeated. Another way of thinking of permutations is to think of them in a permutation tree. For example, the set 1, 2, 3, 4. To come up with the permutations for this set, we can start with the first selection, the selection of the first number. For the first number, there are 4 different things that can be selected. 1, 2, 3, and 4. After this first number has been selected, whichever it may be, say it's 1. After the first number has been selected, 3 numbers remain. So one of these must be selected. Say it's 2. Now 2 numbers remain. One of these must be selected, so say it's 3. Now only 1 remains, so that's that. And this is a way to get all of the different permutations. You start with 1, go all the way down. What are the possible selections remaining? There are 2, 3, and 4. From here, what are the possible selections remaining from the next number? It'll be 2 for a set of 4, and then finally there will be 1. So an easy way to calculate the total permutations is to do n factorial, where n is the number of integers in the set. So n factorial is just n times n minus 1 times n minus 2 times n minus 3. So for this would be 4 factorial. 4 times 3 times 2 times 1. 4 times 3 is 12, times 2, 24 times 1. So there are 24 different permutations. And we can see it like this. For the first number, there are 4 different selections. After this has been selected, for each one of these numbers, there are 3 different ones that can be selected after that. So for every one, which there are 4 different selections, there can be 3 different choices. From these 3 different choices, there can be 2 offshooting off of each one of these. If I pick 3, then there's 2 and 4. For this one, if I pick 4, then there's 2 and 3. And finally, after the second selection has been made from here, then only 1 number remains. 4 numbers to begin with. Then from each of these 4 numbers come 3. From each of these 3 numbers come 2. From each of these 2, there is only 1 remains. So 4 times 3 times 2 times 1. N factorial. For this, 3 factorial. 3 times 2 times 1. You can do this as well, but here it's easy to see 1, 2, 3, 4, 5, 6. 3 times 2 is 6 times 1 is 6.